In this homework video, you'll learn how to find compound probabilities, that is, probabilities with more than one event. And we're going to use tree diagrams to help us. Okay, so how do you find the probability of 2 or more events happening? For example, what's the probability of flipping 3 coins and them all landing heads up? We've already looked at this example. I'm picking it on purpose so that you can see how to do it with a tree diagram. A tree diagram is a way to help you come up with an organized list in a way that you won't miss anything, because it's easy to miss one when you make an organized list. So the way you make a tree diagram is first, up at the top, you label what the first event is. So there's 3 tosses, so there's 3 events labeled at the top. So the first event is the first toss, and on the first time, you could either get heads or you could get tails. So that's the first split in our tree diagram. Then, if you get heads the first time, then you could get heads or tails the second time. If you get tails the first time, you could get heads or tails the second time. So right now, we have 1, 2, 3, 4 possibilities. With 2 tosses, there's 4 possible ways it could go. Heads, 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 tails, tails, heads, tails, tails. We do the same thing for the third toss. So for each possibility that we have so far, we get another 2 options, because on the third toss you could get heads or tails. And so then to come up with our outcomes, we're going to read across the diagram. So you could get heads, heads, heads. So heads, heads, heads is one outcome. You could get heads, heads, tails. Heads, heads, tails is one option. You could get head, tails, heads. Heads, tails, heads is an option, and so on until you get all 8 outcomes. So the answer to the question that we initially asked, there is 1 out of 8 for the probability of getting heads, heads, heads. All right, let's do an example. So go ahead and pause. If you roll a 6-sided die and flip a coin, what's the probability of getting an odd number on the die and tails on the coin? Make a tree diagram to show your work. So the first thing I do is I label what my first event is. I'm going to flip the die, and I know there's going to give me 6 options. So notice how big I spread this out so that I have room to do the rest of my tree diagram. So I label what my 6 options are. Now I'm going to do the second event. So for the second event, now for each roll, I could either then get a heads or a tails. So I'm going to split each number into 2 because the coin has 2 options. So now I have a complete tree diagram, and I can make my organized list. So to make my organized list, I just look across my tree diagram and write down each option. So 1 heads becomes 1 heads. All right, so the question itself was asking what's the probability of getting an odd number and tails. So I'm going to look at what those options are. So odd numbers are 1, 3, and 5. So 1 tails, 3 tails, 5 tails, 1 tails, 3 tails, 5 tails. So that means the probability of getting odds and tails is 3 out of 12, or 1/4, which is 25%. And remember that 12 came from the fact that there are 12 total combinations here, and 3 of them are the favorable outcomes. All right, example 2, give it a try. If you spin the spinner twice and add the results, what's the probability of getting a sum of 7? So if I spin it the first time and get a 2, and then I spin it the second time and I get a 3, that would be a sum of 5. All right, so spin 1 is 1, 2, 3, 4. And then on spin 2, we get 4 more options off of each of them. Because if you spin a 1 the first time, you could still spin 1, 2, 3, or 4 the second time. Finally, I make my organized list. Once I have my organized list, I'm looking for the options that give me a sum of 7. So 3 and 4 would add up to a 7, and 4 and 3 would add up to a 7. So 3, 4, and 4, 3. So that is 2 out of 16 total possibilities. So, which simplifies to 1/8. So the probability of getting a 7 is 1/8. Okay, example 3. If you spin the spinner twice, what's the probability of getting purple at least once? Show your work the tree diagram. Pause. Okay, so once I have my tree diagram showing all 9 possibilities when you spin the spinner twice, I'm looking for getting purple at least once. So red purple would be 1, orange purple would be another, purple purple is another, and we also have to count purple orange and purple red, because getting purple on the first spin or the second spin would count. So that means that 5 out of 9 times, or over half the time, you would get purple. All right, here's our problem set. We've got 4 problems. The first 3 you are going to need to make a tree diagram for. The 4th one, you're just going to write me a sentence.